Okay, we have said earlier that this is the equilibrium position. When the two ions are too close together, there's a repulsive force. When the two ions are too far apart, there's an attractive force. Therefore, we're going to have an oscillation about the equilibrium separation here. So what kind of oscillation do we have when we have the ions with total energy of -6 electron volts? Let's consider at the equilibrium position. If my total energy is -6 and I have a EP of -8 at this position, it must mean that my KE is 2 electron volts at this position. Alright? More importantly, it tells us that our KE is 0 at these two positions here. The reason is because at these two positions, my EPE is -6 electron volts. My total energy is also -6 electron volts. That must mean that my KE is 0 electron volts. I repeat, because we are told that the total energy is -6, the EPE alone is also -6, but EPE plus KE must add up to total energy of -6. That means KE must be 0 here. Likewise here. So these 2 points must represent the extreme positions of your oscillations. So when the ions have a total energy of -6 electron volts, it will be oscillating between these 2 points, with the equilibrium position being here. So we are asked whether this oscillation is simple harmonic. The shortest answer we can give is no, it's not, because if it's a SHM, we expect the EPE graph to be a symmetrical quadratic graph like this, instead of this funny looking graph here. Alright, so that's the easiest answer we can give. If you want to go further, you can also say that because the graph is not symmetrical, it tells us that the restoring force is also not symmetrical. So basically that tells us that the restoring force is not directly proportional to the displacement from the equilibrium position. For example, at this point and at this point, the displacement from the equilibrium position is the same, but you can see that the gradient here is much steeper than here. So in fact, the restoring force when you are this far away is much stronger than the restoring force when you are the same distance away from the equilibrium position. So this cannot be an SHM. Okay, that's all I have to say for this part. Ta-ta!